Okay, so we are reaching the almost the end of this section, and last time we already learned about the concept hierarchy. Okay, so this concept hierarchy, last time I mentioned to you about drilling and rolling. Okay, so roll up means if I have the data is in detail. Okay, so let's say this is, yeah, if the first data is only the detail, so we can roll up and we want to aggregate and based on some higher level. Okay. If we drill down means we want to make more detail. So for example, this one is the city in USA. If we are dealing with drill down, we want to make more detail. For example, the Q1 can be drilled down into January, February, March, okay, and so on. So the concept hierarchy, it can be replacing the low level concepts, for example, numerical values for age. Yeah. We can change to the higher level concepts. So the higher level concept, we can change to youth, adult, senior, instead of using the numerical values. Okay. So the same with the city. Okay. If we have the country, city, state, and street, so those are nominal data. And in nominal data, we can specify the order. We know that the street is the lowest level and country is the highest level. And among those options, we have, for example, street is the lowest one, and then it becomes the city. Okay. So in one city, there will be many streets, and in one state, there will be many cities. Okay. In one country, there will be many states. So yeah, it is a hierarchy. The specification of a hierarchy for a set of value by explicit data grouping. Yeah, for example, this is the example in America. Okay, if we have the state Illinois, okay, then there will be some small city like Chicago or Champaign and Urbana. Okay. And if we have only the partial set of attributes, yeah, it means we have only street and city. So usually when you input your profiles into the system, yeah, they will ask you about your address and you need to input your postal code, or you need to input only the street name, and the system will automatically show you about the street and the maybe the detail about the Myeon up. For example, here is Mohyun up, so it will directly show you the detail about the street and in which city are you living now. We can also use the automatic generation of hierarchies. For example, if we can analyze the number of distinct value. So if we have a set of attributes, we can put it into a list, something like street, comma, city, comma, state, comma, country. So it is in one list. So some hierarchy, yeah, we call this is automatic concept hierarchy generation. So some hierarchies can be automatically generated based on the analysis of the number of distinct values per attribute in the data set. For example, if the attribute with the most distinct values is placed at the lowest level of hierarchy. Okay. As we learned before, country is the top, okay, and then we can go to province or state, and then the next is city, and the next is street. Okay. So the number of distinct values of street are about 600,000. Okay, then we can put it into the lowest level. The country, there are 15 distinct values. Okay, because it is the smallest number of distinct values, then we can put it in the highest level. And the other can be split it into, yeah, maybe it is in the position after the country, and then this will be the position after the state. Some exceptions are related with the time. Okay. So in the time, yeah, it's very unique. Okay. Because when we have year and then when we have quarter, month, weekday, yeah, it is very difficult to make the automatic concept hierarchy. So we sometimes need to do our manual way to make the concept hierarchy of the time. Okay, so I think you already learned many things about the discretization. Okay. So what is discretization? Yeah, if you maybe you already remember this kind of discretization. Yeah. So discretization means, yeah, you want to divide the range of continuous attributes into intervals. So you have numerical attributes and you want to make it into some categories. Okay. And can you mention some of the data discretization methods? Okay. So you can see, yeah, I think you already learned this one. The discretization methods contain of binning, histogram. So those are the typical methods. Okay. But the learning methods related to clustering, decision tree, correlations, yeah, those are more advanced. What is the difference between equal width and equal depth? So in equal width, we will separate the width. Okay, for example, I want to have 3 intervals. Then the intervals will be in between the value that is from the maximum and the minimum divided by the number of n. If it is the equal depth, then we want to get the value based on the number of frequency. Okay, so you can see this one, right? Equal depth is the equal frequency, and the equal width, you want to know the width, which is based on the maximum and the minimum value divided by the number of range that you want to apply. So in this case, if the range is 3, then 34 minus 4 divided by 3, we have 10. So there will be a range of 10 in between of the value. After we have this equal-width, then we will assign each of the value into the bin number 1, bin number 2, and bin number 3. Okay, I hope that is something that you already know because you already learned last time. In the concept hierarchy generation, there are 2 concepts, drill down and roll up. What is the difference? In the drill down, if you have a particular state, you will go into the detail. Okay. Drill down, detail. Okay, that's good. Okay. What about the roll up? You want to make it more higher level, or we want to aggregate. Okay. So there are some examples that we already learned for this one. Okay, let's go to the rapid minor. In this case, I will show you how to do with this tool for some examples. maybe let's use the okay, let me use the local repository, whether I already have the process. Last time we have this example 01, we already saved into the local repository, and last time you also learned how to do saving or export. Okay, so you already learned how to export this one into the RMP or into the XML format. So let's make another process. Let's start from blank. Okay, and then let's use the iris dataset. Okay, let me just read CSV. Okay, and this is the we want to get the CSV file. Okay, where is this one? Okay, in the download I have the data set. Okay, so the iris data set that I gave you before. So we have 4 columns: sepal length, sepal width, petal length, and petal width. And then yeah, I guess those are the basic. Yes, everything is good. And then yeah, sepal length is real value, sepal width is real value, petal length is real value, petal width is real value, and species is polynomial. There is no problem with the data, and then just click finish. Yeah, I just want to see if I run this and I will get the data. So this is the data, and yeah, you can see some statistics about this data. You can do the visualization. Okay, and okay, now you can go back to the design. If you go back to the design, then you will go to this process. Now let's assume that I want to do the sampling. Okay. In this case, let me just use multiply to separate this process. So the multiply here, you can search the operator, multiply, and then you can double click on it. And the output, you can go to the multiply, and then after you multiply, let's say I want to do the sampling. Okay. So there are some sampling approach that we learned before. You can use the sample is like the random sampling. Am I correct? Yeah, this is the random sampling. And then we have the sample or stratify. Okay, so we can use this sample stratify. Let's say if I use this sample, yeah. Okay, the sample size is 100. Okay. Oh, there is a potential problem detected. The example set must contain at least 100 example. Okay, what does it mean? What happened? Yeah, there are 150 examples. So why? Okay, let me check. Okay, let me just delete first. What happened to this one? Yeah, it seems everything is okay. What happened to the sample? Okay, let me just use this sample stratify first. In a sample satisfy, oh, we have 100 sample size. Yeah, what happened? Hmm. 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 Oh, why we have only one? Hmm. Interesting. There is one error, but I do not know. Or maybe let me just change this sample to this data. Oh, something interesting here. So you can see that if I use the iris dataset from this repository, there is no problem. But if I use the rich CSV, there is a problem on the sampling. Okay, let me just try with this sample. Oh, yeah. Okay, then let me just show you with this one. It is interesting. Let me check what is the error later. Let me delete this one. Yeah, you can see that we have 150 data, and after we do with the sampling, okay, if we do with the sample stratify, we only have 99 examples. Okay, we have 100 examples according to the design here. Yeah, we want to get the sample size 100. So it means from 0 until 99. This one, the sample size is 100, but the sample of iris here is 150. Okay, it seems I need to do with this. No, it's not balanced data because I need to do this. What happened? Yeah, for the satisfy, it shows the correct answer because we have the 99 data. Okay, but for the sample, it's so strange. Let me check later. Yeah, even though there's a warning here, actually I can run and show the result. Okay, let me get back later about the errors. So there is also discretize here. So when we do use the discretize, okay, we have the discretize. We can do the discretize by size, discretize by binning, okay, discretize by frequency. So we already learned about binning, and then frequency, it is equi-width, equi-depth, okay. And if it is by size, yeah, it has the different way. Yeah, so we need to set the number of parameter. So if we discretize based on the 3 bins, okay. Oh, what is it? Oh, I need to delete this one. Okay, so after we discretize, okay, and you can see that each of the value here, A1, A2, A3, A4, it means this is, I think, the petal length, petal width, sepal length, and sepal width. And the value now it is in the range. It is in between 5.05 until 5.15. And then this is 4.85 until 4.95. And this is from 4.65 until 4.75, okay, and so on. So we have the range. Okay. So we can determine the range. It is by the size. Okay. So the size is in between three steps. Okay. If you want to use the pinning, okay, yeah, the number of pins, you can determine the number of pins. For example, 3. Maybe I can get it. You can put like this one by discretize by pinning. Okay, so you can change the name, and then if you run, so the pinning result is different. Okay, so it is from minus infinite until 5.5, and then this is from 5.5 until 6.7, and then the highest one is from 6.7 until infinite. So we have 3 pins. Okay, so the pins, the first pin is based on the size. Okay, so we can say we have 3 level. Okay, the first is from 4.95 and then until 5 and then 505. Okay, so it has 3 things, the 3 different steps. But in the discretized by pinning, we want to set the range from minimum until the maximum, and we separate into 3 bins. Or if you want to change, for example, with the discretized by frequency. Okay, then you can also do this one. Yeah, this is by frequency. They determine the range between minus infinite until minus 5.85. Between 5.85 until infinite. So they distinguish into 2, because I think we have the 2 pins here. Okay. When you do this one, actually you can also add some notes. For example, this one, you want to express your opinion. The discretize by pinning explain that the data can be split into for example 3 pins. Okay, so you can explain this one, and you can put this explanation, for example, beside this widget. Okay, so when I give you the kind of assignment of this rapid minor, I hope that you can also explain like this one. Okay, so I will give you assignment maybe on Thursday. I will give you what kind of assignment for next week. Okay. And of course, don't forget, if you already finished with this one, you need to save. Okay. Let's say I have the example 02. You need to select what is the repository. Let's say I want to put in the process, and then I put into the file name example 02. Okay. And if you want to export, okay, then you will do this export. Let's say this is the rapid minor, and then example 02.rmp, and maybe for the assignment you need to send me this .rmp file, so you can explain your name and your student ID. Okay, and yeah, you can save .rmp, and then you can upload .rmp file into the e-class for the submission. And then I will check if your file is working correctly. Okay, maybe I will just close this one. Okay, let me just make a blank, and then if I want to import the process, let's say I use the one that I already created, the rapid miner here. Yeah, I use the bernardo.rmp, so it will show what you already saved in the .rmp file. So if you save your file correctly, then I can open your file. Okay, so please make sure that you save and you also export your process correctly. Okay. Okay, then I will check the errors before. I'm not sure why it errors here. So we already finished this section. Okay, so we learned about the data reduction, which about the dimensionality reduction, numericity reduction, and data compression. Okay. And for the data discretization, we learn about the transformation by normalization. So you learn several techniques for normalization and the concept hierarchy generation. Okay, any questions, comments? So if no comments, then I will continue a little bit about this section. So the next section will be related to the similarity and distance. Okay. This is one of the important concepts in the data mining, because when you have your data and you want to do the clustering, you need to understand this similarity and dissimilarity. So I think I will just give you briefly about the difference between similarity and dissimilarity. We call similarity because we have a numerical measure and we want to see how alike two data objects. So if I have 5 and 6, okay, so I want to know how alike these two data. Okay. Value is higher when objects are more alike. Okay. So if this is similar, yeah, then it can be nearby 1. But if the object is not similar, then the value may be 0. There is another concept, we call it dissimilarity, or we can mention as distance. It is also a numerical measure, and we want to see how difference between two objects. So it's the same like this one. I have, then the first object is 5 and the second object is 6. Okay. So lower when objects are more alike. So if it is more similar, then yeah, we can have lower value. For example, if we have 5 and 6, and then I have 5 and 7. Okay. So if it is more similar, yeah, the value will be higher than this distance. Okay. So if we use the distance, yeah, the distance of this one is higher than the distance of this one. So lower when objects are more alike. Minimum dissimilarity is often 0. Okay. So if we have 5 and 5, of course the distance is 0. And upper limits varies. So maybe if I have like the value is 5 and the other is 1000. Okay, so yeah, you know, 5 and 1000, the gap is very big. So the upper limit is varies. Okay. And the concept is related to proximity. Proximity can be similarity or dissimilarity. Okay, so proximity can refer to dissimilarity, or the proximity can refer to dissimilarity. Okay, I think I will stop here so you can prepare yourself for the quiz.